Okay, in section 4, we're going to look at our last conic section, which is a hyperbola. Now, a hyperbola is a set of points whose difference in distance from two fixed points is a constant. And we'll kind of talk about what that means, but this is the official definition. And these two fixed points are, again, code foci. But instead of adding like an ellipse, it is subtracted. It's a difference. So if I have 2 points, we'll call this one foci 1 and this one foci 2. Then if I take two segment distances, so let's call this D1 and D2. If I subtract those two, it'll give me some number. Well, I guess it would be D2 minus D1. We always do the bigger one first. It equals some constant. And so that would mean this point is on the hyperbola. And then we would do that for other points. Let's say I had another one. Let's say I had a point here, which had a distance to this one of D3 and a distance of this one of D4. Then D3 minus D4 would also equal a constant. And so that would be another point on my hyperbola. So essentially you start to eventually get these two kind of opposing curves, and that's what's going to make up a hyperbola. You can see our example here, and they have some pretty nice properties, similar to an ellipse. So instead of having major and minor axis, we have what's called the transverse and the conjugate axis. So the transverse kind of works like the major axis does for an ellipse, and the conjugate axis works similar to how a minor axis works in an ellipse. We have the other points that you can see on an ellipse that also are on a hyperbola. We have vertices and foci and all those kind of things. So you see the vertices in this case are on the major axis, and the foci are also on the major axis. So we have the vertices and the foci. The focus are inside the curve, just like a parabola, just like it was inside the ellipse. Vertices on the axis. And we don't really have covertices as we did in the ellipse, but what we have is we have these asymptotes. And these asymptotes, one positive and one negative sloped, are going to kind of guide what our hyperbola looks like. So the only real difference could be is if my vertices were, say, on this axis, then my hyperbola might go up and down like this. So similar to an ellipse, we'll have an equation when the transverse is horizontal, one when the transverse is vertical, and then we'll kind of have ways A, B, and C to figure out the vertices, the foci, and a way to find the asymptotes. So we have two equations for hyperbolas, really, again, depending whether the transverse axis is along the x-axis, so that would be horizontal, or along the y-axis with the vertical. And again, we'll start if they are centered at the origin, and then we can change like we always have. So if it's centered at the origin and has one transverse axis horizontal, then we have x squared over a squared minus y squared over b squared equals 1. And so very similar to what you saw for an ellipse, except for we have a subtraction sign instead of a plus sign. And A is going to be the distance from the center to the vertex. C is the distance from the center to the foci. And B really doesn't have a point it goes to, but it is part of the asymptotes that guide the hyperbola. So the key thing here is whatever your transverse axis is, that variable is going to go first. If you look at the second one, where it's going to be transverse along the y-axis, you can see the y squared goes first. So A, again, is going to be center to the vertices. C is going to be center to the foci. And B is just kind of really used in the asymptotes. And you can see the asymptote equations. The asymptotes are actually given by the B and A value. The asymptotes are y equals plus or minus b over a x. So the slope is determined by the b and the a. When the transverse axis is along the y-axis, you can see it switches, and the a and the b switch. A is on top and b is on bottom. I'll show you a way where you can kind of see this in the picture when we do some examples, so you don't actually have to memorize which one goes on top, b or a. Also similar to an ellipse, we have a new equation, b squared equals c squared minus a squared. So a little different than the ellipse one. Ellipse was a squared minus c squared. And the reason it changes is, remember, c is further away from the center than is the vertices in this case. So we have to make the bigger numbers minus the smaller numbers so we can have a positive distance. So again, the only difference between the two is the difference in the asymptotes, and of course, what variable comes first is going to determine what our transverse axis is. So let's look at an example, a couple examples of how we can do this. We'll start by writing the equation of an ellipse or a hyperbola. So we want to find the equation of a hyperbola with a center at the origin. So we'll go ahead and say we know our center is at 0, 0. It has a foci at 8, 0, and it has a vertex at 4, 0. So what I want to do is first I want to try to figure out what is my transverse axis. Is my transverse axis going to be the x or the y? So I'm just going to kind of sketch a picture here. My center is going to be here. My vertex is going to be here. And then my foci is going to be here. So I can definitely see all the good stuff is happening on the x-axis, so the transverse axis is going to be on the x-axis. And then my hyperbola would look something like this. So a couple things I know right away. I'd like to know what A and B and C are. Well, I know A is the distance from the center to the vertex, so that's got to be 4. I know C is my distance from my center to my foci, so that's going to be 8, because my foci is 8, 0. Now, I don't know B, but I will need it to find the equation. But I know that b squared equals c squared minus a squared. That's the relation that is true for all hyperbolas. So b squared is going to equal 8 squared minus 4 squared. So b squared is going to equal 64 minus 16. So b squared is 48. If you want to find b, that's fine. It's the square root of 48. Or if I simplify, that's 4 square root of 3. I really don't need it though, because really what I need for the equation is I need b squared, which I know is just 48. So when I write my equation, since the transverse axis is x, I'm going to put the x squared first. And I'll put the y squared second. Now a squared is going to be 16, so the a squared always comes first. The thing that determines in the ellipse, remember, is what was bigger. Determine what the major axis is. In a hyperbola, it's whatever variable comes first, because you can always switch addition, but you can't switch subtraction. And then b squared is going to be 48. Now this is only part of it, because we also want to find the equations of the asymptotes. And so you can look above and see if it's b over a or a over b, but I'm going to give you a real quick trick to show you how to do this. Well, I know the slope of this asymptote is going to be up this direction, rise over run. Well, based on this picture, I know this distance has to be a. And so if this distance is a, this distance is b. So it's a because the horizontal distance is always the run, so it goes on bottom. So I know the asymptotes for this have to be b over ax, rise over run. So the asymptotes are going to be 4 square root of 3 over 4x plus or minus. So I can simplify that to be y equals plus or minus square root of 3x. So my slope is square root of 3 over 1 or something like that. So that's just a real quick way, because you kind of always know what A is. A is either going to be your rise or your run. If your A is your rise going up and down, it goes on top. If it's your run, it goes on the bottom, just like all slope that we've always known. So let's look at a couple other examples. This first one, you use 4y squared minus x squared equals 16. So the first thing I see is it needs to be put in standard form with the 1 on the other side. So I'll go ahead and divide everything by 16. That's going to yield y squared over 4 minus x squared over 16 equals 1. So now a couple of things we know. We know its center is 0, 0, because there's nothing in the xy. The transverse axis in this case is the y-axis, because the y comes first. And then as far as A, B, and C, we know A is 2, because remember, A squared always comes first, and we know B squared is 4. I don't know C squared, but I can find it because I know B squared equals C squared minus A squared. So that would be 16 equals C squared minus 4. So C squared equals 20. So C is equal to the square root of 20, or 2 square root of 5. And square root of 20 somewhere between 4 and 5, and that'll help us when we start to graph this thing. So what I'll go ahead and do is I know the transverse axis is the y-axis, so I know the vertices and the foci need to be on that axis. So A is 2, center is going to be here. So my vertices are 2 away because A is 2, and that's center to vertices. So I know those are 2 points on my hyperbola. And then my foci is determined by C, so center to foci is 2 radical 5. So it's somewhere up here. So we'll say 0, 2 radical 5, and somewhere down here, 0, negative 2 radical 5. I could also do my vertices, which would be 0, 2, and 0, negative 2. So now I have to figure out what my asymptotes are. Now remember, the slope of the asymptote is either going to be B over A or A over B. Well, let's go ahead and look. Our A distance in this case, A is centered at the vertex. So A is going up. So I know it has to be this one because my A is my rise in this case, not my run. So I know without memorizing any formulas, my asymptotes will follow the equation A over BX. So if I write that for this one, that's going to be 2 over 4x or 1/2 x. So if I look at it, this has a slope of 1/2 and no intercept, so it'll start at the origin. So up 1 over 2 will make an asymptote that looks something like this. And down 1 over 2 will make an asymptote that looks something like this. So we're just trying to get kind of guidelines to see how our hyperbola will fit. So now that I have those, I can kind of go through the vertices and just kind of go along those. I know the hyperbola has to go through the vertices, so I know it has to go up and down, it has to cross that transverse axis, which in this case is the y-axis. Okay, let's look at this next problem down here, if I can get it to go down there. So this problem is x squared over 2 minus y squared over 4 equals 1. So let's go ahead and take care of some of the basics, such as what is our center, what is our transverse axis, and then we kind of need to know what A, B, and C are. This is kind of how we'll start all these problems when we're trying to graph. So center is going to be 0, 0, because again, nothing in the x and y. And the transverse axis in this case is the or the x-axis, because the x comes first. Now A, remember, A squared is under the first term and B squared is under the second term, no matter which one is bigger. So A is going to be the square root of 2, and B is going to be 2. Now as far as C, remember B squared equals C squared minus A squared, so we'll just have to work that out. So B squared is going to be 4 equals C squared minus 2. Add 2 is 6, so C squared equals 6. So C is square root 6, which is, just for our note, about 2.3-ish, just so we kind of know where it lines up on our graph. So let's go ahead and put some of these points on our graph. So here is our center at 0, 0. Now the transverse axis is on the x-axis, so we're going to go out both directions for our vertex on that axis. So that's going to be square root of 2, 0, and negative square root of 2, 0. It's like 1.4, so something like that. Now our foci are going to be 2.3 units away, so the foci are somewhere like right here, and they'd be radical 6, 0. So if I'm kind of trying to jam all that in there, and this foci negative radical 6, 0. And so really the big thing we want to have here is our asymptotes to kind of form our thing. Well, remember, we went this way from the center for the A, so that means the A part of our slope is the run, so the slope of the asymptotes has to be B over A. So that's going to make it y equals 2 over radical 2, of course, plus and minus x. And if I want to rationalize that, that actually becomes radical 2x plus or minus. So our slope is like 1.41 over 1, because radical 2 is like 1.41x. So we're going to go up 1.41 and over 1. So it's going to look something like that. And down 1.41 over 1. So it's going to look something like that. So those are our asymptotes. We have our asymptotes. We have our equations of our foci and our vertex, our vertices. And so then our hyperbola will go through the vertex and kind of approach those asymptotes. Now again, it's remember that you go through the vertex, and remember they just kind of approach that like that. So there are two graphs of two hyperbolas, one with a transverse axis on the x and one with a transverse axis of the y. Okay, let's go ahead and look at a couple that are not centered at the origin. So if you look at these two equations, they look very similar to the ones we had before. I just want to point out a couple things. So one, you have the h and k, which are our center, changed in our two hyperbola equations. Now again, if x comes first, then the x is still the transverse axis, but it wouldn't be the x, it would be the line parallel to the x. And if y comes first, then it's some line parallel to the y-axis. And not only do the equations change, but you can also see the asymptotes change. Another way to write this that might make it a little easier, instead of writing, I mean, these are fine, you could also write it as y minus k, just making the same replacements as we did before. For the asymptotes works just as well. Obviously, the way it's written here, you could just add k to both sides, but if you just move it k and move it h, that works just as well as doing it this way. Same thing with it for the transverse on the y, a over b, x minus h. So either way is fine for the asymptotes, but it's just like every conic we've done. You're just changing it by hk, just changing where the center is. Same relation hold, b squared equals c squared minus a squared. So really nothing else crazy there. So let's go ahead and look for the equation of 1. We'll graph 1, and then we'll try to do one where we complete the square. So this one says find the equation of a hyperbola with a center at 4, 8. And I've just kind of got something here just to kind of mark just for our benefit. So center at 4, 8. It has a foci at 4, negative 2. So 4, negative 2 would be here. And a vertex at 4, 10, which would be right here. So what I noticed right away is I know my center is 4, 8, and my transverse axis is going to be y. It's not technically going to be y, because remember, it's really this axis is my transverse axis, the x equal 4, but that's going to mean in our equation that y will come first. Now, as far as a, b, and c, I know what those are, because a is how far from the center to the vertex, and that's just going to be 2. And then the center to the foci is going to be 10, because we're going from 8 to negative 2. So that's going to be 10. And then the rest we can kind of fill in and figure out what b is, because we know b squared equals c squared minus a squared. So b squared is going to equal 10 squared minus 2 squared. So b squared is going to equal 100 minus 4, which is 96. If I wanted to know what b is, it's the square root of 96, or 4 radical 6. But for our equation, all we really need is b squared. So now we can write our equation. So I'm going to start with the y, because the transverse axis is the y, something squared, and then I'll have the x second. Now I have to put my center in there, so it's going to be minus 8 and minus 4. because in our center, the x is still the x and the y is still the y, so it still goes with each other, equals 1. Now a squared always goes first, and b squared, which is 96, will go second. So this is the equation for my hyperbola. Now asymptote-wise, remember, a went up, so a is the rise in our slope, so it's going to be a over b. So if I want my asymptotes, I'm going to take the same things that I have up here because I'm just shifting the y and x. I can just take these two for my new x, my new y. So it's going to be y minus 8 equals plus minus a over b. So it's going to be 2 over 4 radical 6 x minus 4. And you can, of course, clean up that slope. Not squared. It's an asymptote. So you can clean up that slope if you want. This reduces to 1 over 2. So it'd be y minus 8 equals plus minus radical 6 over 12 x minus 4 if you wanted to rationalize it. It would look something like that. So we've got our hyperbola equation and our asymptote equations. Okay, let's go ahead and look how we can graph one of these. So we have y minus 1 squared over 8 minus x plus 1 squared over 4 equals 1. So first I pick out my center. Now my center is going to be negative 1, 1, because I'm taking the opposite of x and the opposite of y. And my transverse axis is going to be the y-axis, or parallel to the y-axis, because the y comes first. Now as far as a, b, and c, right away I know a is going to be the square root of 8, or 2 radical 2, which is about 2.82, just to help us out down the line. And b is going to be 2, because remember this is always a squared and this is b squared. So we can find c. Same way we have before. We know b squared equals c squared minus a squared. So b squared is 4 equals c squared minus 8. So c squared equals 12. So c equals the square root of 12, or 2 square root of 3. So I would start with this first. So I would go to my graph, and I'll graph my center first, negative 1, 1, which is over here. That's my center. And then my vertices are going to be up and down, remember, because the transverse axis is vertical. So I'm going to go up about 3 units. So about here. So this vertex, now remember, this was negative 1, 1, and I'm increasing the y value. So it's going to be negative 1, 1 plus 2 square root of 2, whatever that number is. And then I can go down the same amount, and this vertex is going to be negative 1, 1 minus 2 square root of 2. The foci are 2 square root of 3, square root of 12, so it's a little over 3. So I'm going to have a focus here, and I have a focus down here. And this focus up here is going to be negative 1, comma 1 plus 2 radical 3. And this one down here, similarly, will be negative 1, 1 minus 2 radical 3. So the last thing I have to figure out to kind of get a good graph of this is the asymptote. But remember, we went up with A to get to the vertices from the center. So my A is my rise, so my slope for my asymptotes will be A over B, similar to the last one we just did. So that's going to be y minus 1 equals plus minus A over B, so that's going to be 2 radical 2 over 2, which will cancel, x plus 1. So y minus 1 equals plus minus radical 2, x plus 1. And interestingly enough, when I'm graphing, all I really care about this is the slope, which is 1.41. Let me zoom in here and kind of show you what I mean. So with this slope of 1.41 over 1, when I'm graphing my asymptotes, I'm going to start at the center. So you could distribute it and get it all to find the actual intercept, but I really don't care. Because if I start at this center, go up 1.41 over 1, there is going to be one of my asymptotes. And I'll do the same thing from this center. I'll go down 1.41 and over 1. And there is going to be my other asymptote. And then my graph is going to go through the vertex and approach those asymptotes. So this is a pretty good sketch of what our hyperbola would look like. So again, the big things are picking your center, finding what your transverse axis is, finding A, B, and C, figuring out what you have, figuring out what you don't have, and then just really counting boxes and knowing where the distance to A, B, and C really represents. Let's look at one final example. This one says graph the hyperbola, state the coordinates of the vertices, foci, and equation of each asymptote. So this is one where it's in the general form where we have to kind of complete the square to get it to work out correctly. So what I'll do is similar to other ones, I'll go ahead and I will get the x terms together and the y terms together. But remember, just like we've done a bunch of times before, and I'll move the 36 over here, we have to make sure that the first term is a 1. So for the x's, we're golden. So it's x squared minus 16x, no problem. But for the y's, you notice there's a negative 4 out in front of it. So I'll have to factor out a negative 4. So that'll make that y squared minus 6y equals 36. So now my complete the square terms, remember, is half of the middle squared. So half of negative 16 is negative 8. Negative 8 squared is 64. So I'll add 64 to both sides. And it's this next one's a little tricky because I'm doing half of negative 6, which is negative 3. Negative 3 squared is 9. But you have to be very, very careful because this 9 is inside the parentheses with this negative 4. So adding a 9 inside the parentheses is really like subtracting 36 because negative 4 minus 9, or times 9, is negative 36. And that's a key thing when you're doing these complete the squares. For an ellipse, we just had to multiply by the number. Now it's a negative number. So I will have to subtract 36 from both sides. Because I'm doing it to this side, I have to do the same to this side. So that's really the trick. The rest is pretty much factoring as perfect squares. This is y minus 3 squared. This is 64. And so now I can simply just divide out by 64 to every term to make that clear out. So I have x minus 8 squared over 64 minus y minus 3 squared over 16 equals 1. So really all that work was just to get it to a form where I can kind of work with it, where it's kind of in the standard form, where I can pick out my center and transverse axis and all the other cool stuff that we need to graph the hyperbola. So let's go ahead and write some of that down. So I know the center is going to be 8, 3. I know the transverse axis is going to be parallel to the x-axis because x comes first. I know A is 8 and I know B is 4. I can find C, of course, because I know B squared equals C squared minus A squared. So that's 16 equals C squared minus 64. That's 80 equals C squared. So C is the square root of 80, which is 4 radical 5 if I want to simplify it. So with this little bit of information, with this, I can pretty much graph the whole thing. I haven't done the asymptotes yet, but I certainly can. So 8, 3. 8 and 3 is going to be right here. And my A is 8. So if I go 8 over, I'm going to have a vertex here at 0, 3. And unfortunately, I'm going to have a vertex way over here, which is going to be at 16, 3. So I'm adding A on both sides. Now, if I think of the foci, 4 radical 5 is real close to 9, so it should be just slightly past there. So remember, the center was 8, 3, so I'm adding on to the x. So it's going to be 8 plus 4 radical 5, comma 3. And just slightly past here, 8 minus 4 radical 3, comma 3. Or radical 5, pardon me. So those are there. Now for asymptotes, A definitely went this way to get to the vertex, so my slope for the asymptotes, I know A will be on the bottom, so B will be on the top. So that's going to make my slope 4/8, or of course that could be 1/2. And then I'll have my x minus 8 and my y minus 3, the same thing I had from my original. So those are my asymptotes. There's my vertex. There's my foci. And again, if I want to graph those asymptotes, the slope's 1/2. So up 1/2 from my center would be there, and down 1/2 from my center would be there. And then just remember it goes through the vertices. So something like this. So hyperbolas, again, just like ellipses, just like parabolas, just like circles, they just have certain properties that you kind of have to apply. Count some spaces, figure out where the different points are on your graph. So obviously, hopefully, if you have any questions, you'll let me know, but hopefully this is not too bad for our last conic section.